Bonsuelo, everybody. Okay, today we're going to add something to factoring, and I mean something completely new, not like some sort of variation on the ones we've done before. But first of all, I just want to review very quickly what I've told you to do in the past. So you should know all this already. This is not new. I'm not going to spend a lot of time on it. You have the greatest common factor. That's the first thing you always look for. The second thing you should always look for is a trinomial or difference of two squares. You look at the first term, look at the last term, and check with the middle term. And these are all examples of things you should be able to do. So, pause the video and take a look at them. Okay? So you should be able to factor all of these. Notice, originally when I taught you to factor, I said the difference of squares. But I've also since then shown you how to factor the sum of squares using imaginary numbers. Okay? Now, what's new? Factoring perfect cubes. All right, what this is. First of all, let me make sure you understand what I'm asking you to do. What I'm not asking you to do, I'm going to write some stuff down here and don't you write it. I'm not asking you to do this. Or this. Okay, that is already factored. That's not what I'm talking about. I'm not talking about a quantity cubed. I'm talking about, because these are factors. What I've written here, these are factors. Remember, what are we doing? We're taking something that's terms and changing it into factors, things that are multiplied. Notice these are terms. How do I know? Because there's a plus and there's a minus. They're terms. So we're taking terms and factoring it, pulling it apart into things that are multiplied or divided. Okay, it's just a formula you need to memorize. Either you memorize it or you don't. If you memorize it, you have a chance of getting it right. If you don't, you don't. But there's something I want to point out. It looks like two formulas, and I guess maybe technically it is, but it's not really. Let me show you why. Okay, I'm just going to scribble on this for a second. Don't write any of this down. Let's take out the plus and the minus. Notice they look the exact same. Okay, you have a cubed, b cubed. Then you have the first factor is AB. By the way, how do I know this? This is just a formula you memorize. I could show you why it works, but if you just multiply it all out, you'd see that it works. So you have AB in the first set of parentheses, and the second set of parentheses is A squared, then AB, then B squared. Okay? Look at it. It's the exact same. So what's the difference? Whatever sign goes here, that sign goes there also, and then the opposite of it goes there. Okay? All right, so let me show you. Okay, so if this is plus, then you go plus, minus. If it's minus and then plus. Okay? Other than that, it's the exact same. And you know what? It's just a matter of memorizing this formula. Either you memorize it or you don't. Okay? It's not real magical. It's kind of like the quadratic formula. You either had it memorized or you didn't. Okay? Let me point out something, though. You should always, remember, once you're done factoring, you should always look to factor again. Okay, I'll save you the trouble with these quadratics that you end up with. As of right now, you will not know how to factor those. Okay, so I'll save you the trouble. You do not have to look right now. Eventually you will. You do not have to look to figure out how to factor those. All right? So, because you won't know how to do it right now. All right, now this part of it, you may need to factor it again. It just depends on the problem. Okay, so let's just take a look at examples, and it's just a matter of going through a lot of examples. Okay, what you're going to do is this. Take this and write it as something cubed. Then plus. Take this and write it as something cubed. Okay, what times itself 3 times will give you x to the 6th? That's x squared. What times itself 3 times gives you 125? That's 5. And then this is what you do. Wherever you see a in the formula, you put x squared. Wherever you see b, you put 5. It's really, or I look at it this way. This is kind of how I write the formula. Okay? Whether it's the first one, the second one. First one squared, first times the second, and the second one squared. Okay? And then it will always be plus here. Sorry. It will always be plus here. And then whatever this sign is, you put it there and the opposite of it there. But this last one's always plus. Okay, so let's take a look at an example. And there's nothing really magical about this. I've already written it out for you, but I just want you to see me do it. Okay, I'm going to put a set of parentheses into a larger set of parentheses. And then I'm going to take the first one. Sorry, let me erase that and try and write it a little clearer. More clearly. I'm going to take the first one, which is x squared, and then the second one, which is 5. Okay? Then I take the first one, what's in the first set of parentheses, and square it. Then I take the first one times the second one. When I'm talking about the first one, I'm talking about what's in the first set of parentheses, x squared. And when I talk about the second one, I'm talking about what's in the second set of parentheses, that's 5. So, and then last thing is 5 squared. And it's always plus. And now, because the original problem was plus, I make this plus and this minus. And then you just simplify it. So x squared squared becomes x to the 4th. This just becomes simply 5x squared, and this becomes 25. So again, let me go through that again kind of more slowly. Okay. X squared is the first one, and 5 is the second one. So I take the first one, and then the second one. Then I take the first one squared. The first times the second. And then plus the second one squared. And then whatever the sign is between them, I put that sign here and the opposite there. And then you simplify it into this thing. Okay? And quite frankly, just everyone is going to be like that. So I just want to go through some examples and then just kind of give you an idea of things to be careful of. All right? Okay, so there are a lot of examples here. First thing you have to do, remember, there are 3 questions here. Greatest common factor, difference of 2 squares or a trinomial, perfect cubes. And always look for them in that order. Greatest common factor first, difference of 2 squares or a trinomial next, and then cubes. Look for cubes last, okay? All right, so let's take a look at number 1. There's no greatest common factor, no difference of 2 squares or trinomial. This is perfect cubes. So it's x cubed plus 2 cubed. So whenever I say the first one, I'm talking about x, and whenever I say the second one, I'm talking about 2. So we have the first one and the second one. First one squared, first times the second, and then plus the second one squared. And then because there's a plus between them, I'm going to put a plus here and a minus there. And this simplifies into x plus 2 times x squared minus 2x plus 4. And again, you'd normally look to see if you could factor this again. I'm just saving you the trouble. Don't look at the trinomial. You won't know how to do it. We'll get to that eventually. Okay, let's take a look at this. Well, what's this x? First of all, there isn't going to be any greatest common factor in any of these. Not that there couldn't be, I just didn't put any in here. Okay, what's this thing? This is a cube. Okay, x times x times x is x to the third. What's 6? Well, it's not a cube. There's nothing times itself 3 times that gives you 6, and it's not a square. So you can't do this. They have to both be cubes or both be squares. Okay, the x to the third is a cube. 6 is neither a square or a cube, so you can't do it. Okay, let's take a look at this. This is a cube. X squared times x squared times x squared gives us x to the 6th. And 8 is a cube, because 2 times 2 times 2 gives us 8. So we can rewrite this as x squared cubed minus 2 cubed. And in a second, I'll talk about how to tell the difference between a square and a cube, but you have to be able to recognize it. So wherever I say the first one, I'm going to put x squared. Wherever I say the second one, I'm going to put a 2. So there's first one, second one. First one squared. And if you want to go straight to calling that x to the 4th, go ahead. First times second. And if you want to just call that 2x squared right off the bat, go ahead. And then plus the second one squared. And again, if you just want to call that 4, that's fine. And now, in the original problem, this is minus, so you put minus and then plus. So this is x squared minus 2 times x to the 8th plus 2x squared plus 4. Now, for the time being, see this, again, the trinomial, you don't have to worry about factoring it. You can actually factor x squared minus 2, but Alex is not going to have you do this. So it's fine with me if you just leave it that way. But just so you know, we could do this as x minus square root of 2 on paper and x plus square root of 2. And then times x to the 8th, you don't need to write this down, plus 2x squared plus 4. Okay, but Alex is not going to have you do that on paper. Yes, you would, but okay. All right, now let's take a look at this. This is a cube. X squared times x squared times x squared is x to the 6th. This is neither a cube or a square, so you can't do this. Okay? And again, in a little bit, I'm going to summarize something about, or try and give you an idea of how to find squares and cubes. You have to look at numbers and exponents differently. And I mean, I'm not telling you anything new about that. It's just a matter of knowing the exponent rules. Okay, x to the 4th is not a cube. It's a square. Sorry, x to the 8th. X to the 8th is not a cube. Okay, it's a square. And 125 is a cube. So x to the 8th is a square, 125 is a cube. So this is neither completely squares or completely cubes, so you can't do this. Now at this point, I'm going to write some stuff down, and you don't need to write it down. But I want to look at some numbers and say, is this number a square or is this thing a cube? And I just want to kind of give you an idea that you have to look at exponents and numbers different, just straight numbers differently. So you don't need to write any of this down. You may if you want, but it's not any problem. Okay. Let's take a look at, x to the 4th. Okay, that's a square because it's the same as x squared squared. It's not a cube. Let's take a look at just 4. Just the number 4. That's a square because it's 2 squared and it's not a cube. Okay, here's where we might start running into difficulty now. Let's take a look at just the number, at x to the 6th power. Okay, that is a square because it's x to the 3rd squared. Okay? But it's also a cube because that's x squared cubed. So x to the 6 works as both a square and a cube. Okay, how about 6? Just the number 6. That's neither a square nor a cube. There's no number, an integer, we're not going to deal with square roots here. There's no number that when you multiply it by itself will give you 6, and there's no number when you multiply it by itself 3 times that gives you a cube. Okay? How about x to the 8th? Okay, that's a square because it's x to the 4th squared. It's not a cube at all. There's nothing times itself 3 times that gives you x to the 8th, because x to the 2nd times x to the 2nd times x to the 2nd doesn't give you x to the 8th. It gives you x to the 6th. Okay, how about just the number 8? Okay, it's not a square. There's no number times itself twice that gives you 8, but it is a cube. The point I'm trying to make here is you have to look at numbers and exponents differently, right? I think I've shown you this before, and I'm going to write one more thing down here, but don't write it down. Remember, we had this problem, 20x to the 20th over 4x to the 4th, and I said simplify that, but don't write this down. Well, what's 20 over 4? It's 5. You simply divide. But x to the 20th over x to the 4th is x to the 16th. You deal with numbers and exponents differently. Okay? I don't want to belabor this. I want to, take time to go through problems. But you have to remember to look at exponents and just simple numbers differently. Okay? So I'm going to get rid of this thing now. So if you want to copy it, you can, stop the video and copy it. But I need some room to actually solve the problem. So, okay. Okay, let's take a look at the next one then. This is a cube and a square. This is a cube. So the whole problem is cubes. So we've got this as x squared cubed plus 5 cubed. Okay, if I remember correctly, this is the problem we did. Yeah, it's the same problem we did up here in that example. So I'm not going to spend a lot of time on it, but so we have the first one, the second one, the first one squared, first times the second, and then plus the second one squared. And because this is a plus, it's going to go plus and then minus. So we got x squared plus 5 times x to the 4th minus 5x squared plus 25. And again, we could factor the x squared plus 5, but you don't need to write this down in x plus the square root of 5i and x minus the square root of 5i. But we're not going to do that. Alex is not going to require you to do that, and we'll worry about that later. Okay? I just want to point it out. Okay, what's this? X to the 8th is a square. 16 is a square also. Okay, so what is this? This is just first term, last term, check with the middle. That's all it is, right? So what times what gives you x to the 8th? It's x to the 4th times x to the 4th. This is not a formula. This is just regular factoring. We did this, back in chapter 0 and chapter 4. What times what gives us negative 16, negative 4, and positive 4. Okay, now can we factor this again? Well, this first one is the difference of squares. So it's what times what gives us x to the 4th, x squared and x squared. What times what gives us negative 4, negative 2, and positive 2. And we're not going to factor the x to the 4th plus 4. Sometime in the future we'll do that, but it's not that hard. You just have to use I. Okay? And again, you could factor this using square roots. You could factor this using square roots and I, but we're going to hold off on that for now. We'll do that eventually. Okay? All right. X to the 6th minus 16. Well, this is a square, and this is a square. Well, remember, x to the 6th can be either square or a cube. So if you're looking up here at example 3, notice it was a cube. Why did I treat it as a cube? Because the 8 was also a cube. Why in example 8 am I treating it as a square? Because the 16 is a square. So you have to look at what both of them are. So this is going to be, again, this is going to be squares. So just first term, last term, check with the middle. So we have x to the 3rd times x to the 3rd gives us x to the 6th, and minus 4 and plus 4 gives us negative 16. And then you can't factor it again because those aren't either squares or cubes. Okay, the reason why I like this number 9 is it makes you look at the difference between numbers and exponents. Okay, first of all, these are both cubes. So what cubed gives me x to the 27th? Think about it for a second. It's not x to the 3rd, it's x to the 9th, okay? And what cubed gives me 27? It's not 9, it's 3. So when I say the first one, I'm talking about x to the 9th. When I'm talking about the second one, I'm talking about 3. So what do we have? We have first one, second one. First one squared. First times the second. And then plus the second one squared. And then because the original problem was a plus, that's a plus and that's a minus. So we get x to the 9th minus 3 times x to the 18th minus 3x to the 9th plus 9. And none of that factors again. Okay, problem B here. I'm going to show you something. I'm going to show you the way Alex is going to deal with it right now. And then I'll kind of mention how you'd really deal with this. But since Alex doesn't do it the complete way yet, I wouldn't require you to do it right now. Eventually we will. Okay, so all Alex does is take the cube root of both sides. And the cube root of x cubed is x, not the absolute value of x, by the way, just x. And the cube root of 125 is 5. Now, I've told you that x cubed equals 125 should have 3 answers. It does. And I think I might have mentioned this in a previous video. Okay, what would be the technically correct way to do this? Okay, I'm just going to show it to you here. You don't really need to know it now. The technically correct way to do this would be to set it equal to 0, factor, so this would be x minus 5 times x squared plus 5x plus 25. Okay, this one is just going to give me x equals 5. This one does not factor, but notice it's a quadratic, so I could use the quadratic formula, but you don't need to worry about this for right now. It is coming eventually, but for now, just take the cube root of both sides and x equals fine is fine. So we have x would be negative 5 plus and minus the square root of 25 minus 4 times 1 times 25 all over 2 times 1. Okay? Now, what would this part in the radical give us? I'm not going to finish this problem off. I'm just saying this is how we'll do this do it this way later. But notice the thing under the radical gives you a negative, because it would be 25 minus 100, which is negative 75. That's going to lead us to an imaginary number, which is okay. That's what it is. But Alex hasn't gotten there yet. So I really wouldn't have given you this problem here normally, but Alex did, so I'm kind of out of luck. I just got to go with what they give you. But for right now, again, you don't need to worry about this, okay? I'm just saying eventually it's going to come. I just don't want to, like, start doing what Alex does, which is this, and then all of a sudden start taking the, factoring it and using the quadratic formula without kind of alerting to it at least a little beforehand. Okay, so basically what you need to do is factor perfect cubes, okay? All right, hope that helps everybody. Have a good day. Bye-bye.